got to this problem, or we got through this problem, correct? We did all of these yesterday? Yes? Okay. Did we do this problem? No? Okay, so do you guys remember stay and go? No? Anyone? Does anyone remember stay and go? A little bit? Okay. So when we were talking about our negative exponents, one of the methods I taught you was to move it so it's positive and then take care of it. You don't have to do that. You can just apply the rule if you like and subtract the two exponents because they're on top of each other. If you want to do that, that's fine. Remember that whatever answer you get when you do that is on the top. And so if it's negative, it has to go to the bottom. So that is one method to do this, is to actually just use our rule, our division rule. The other method is to rewrite this so that everything's positive. What do we have to do with that 48 and 36? What do we have to do with the 48 and 36? What? Divide? In what way? Can everybody take the earbuds out so that I actually know that you're not listening to them? Out. You can listen to music all you want while you're doing work time. But while I'm teaching, music is not on. You can't do both. I'm sorry. What do I do with my numbers? Take out the greatest common factor. What common factor do 48 and 36 have? 12. So 48 divided by 12 is 4. 36 divided by 12 is 3. Nice job, babe. Okay, so now I've got F's and G's, and they're all mixed up. And some are negative and some are positive. So if I do my stay and go method, F to the negative 4, is that going to stay where it is, or does it have to go to the bottom? Goes to the bottom. So F to the negative 4 would then become F to the 4th. Okay? G to the 8th. Is G to the 8th going to stay or is it going to go? Stay because it's already positive. I'm going to put that over here so I can line my F's and my G's up. Okay? Because they're messed up here. I want my F's and my G's to be in the same line. Okay? G to the 3rd, is it going to stay or go? Stay. F to the negative 9, is it going to stay where it is or go to the top? Go to the top. Why? Because it's negative. And then it's going to be positive. So all we do is get rid of my negatives. So now we can look at that and we can decide, oh, that's easy to do. My 4/3 stays the same. I've already taken care of that. Now let's take care of our F's. What am I going to get? Brooklyn. F to the 5th. Top or bottom? Why? What? Because the biggest number's on top. F to the 5th. Okay. G to the... Show me on your fingers. What's it going to be? G to the what? Okay, so 3 of you, 4 of you know what you're doing. G to the what? What do I have to do with my 8 and my 3? What do I have to do with my 8 and my 3, everybody? Subtract. 8 minus 3 is 5. It's on top because it's positive. If my 8 would have been on the bottom, then it would be on the bottom because it would have ended up being negative. Okay? Questions on that? This question, I think I talked about this yesterday. C and D are your answers because we only deal with one. We never dealt with, this would be chapter 10 or 9 or 8, whenever we did factoring. So this would be factoring, this would be chapter 7. Okay? All right, how many of you tried the back? Good question. How about number 9? How do I rewrite that? I thought we discussed this yesterday. No? Okay. So how do we rewrite that? It's the same as what? 256 to the what? To the 1/4 power, right? So I'm going to do 256 caret 1/4 in parentheses equals. Enter that into your enter that into your calculator. What do you get? 4. Nice job. 4 is what you should get. If you don't get that answer, then figure it out. If you had 3 square root of 81, but this was cubed, the cube root of 81, how would you write that one? How would you rewrite this? 81 to the 1/3. Then you would enter it in your calculator. Good? Alright, we gotta cruise, guys. We got other stuff to do. So you're gonna have to wake up a little. Alright, if I am looking at number 10, how do I do that? Put the 8 to all of us. Just distribute that 8. Okay? And everything stays where it is. It just gets 8 higher. Or 8. Scales up by 8. 8 times it, yes. So 8 times bigger. That's what I meant. Thank you, Miss Erin. So, what's my first thing going to be? -1. Okay? I would like you to do that if you haven't done that. Before I give you the answer, I'll give it to you before the end of the hour. What about subtraction? What about subtraction? So I'm going to do 7 minus 6. Then I'm going to do, you don't have to, not with this one. Because you'd have to switch them in all of it, and you're going to screw that up because you're going to miss one. This one you can just outright subtract. With a parentheses, yes, I'd like to do that. And you can do that, maybe, if you'd rather do that, and then add, do that. But most people screw that up. Okay? How am I going to get this position? -2 minus 8. Okay? So this is going to be 1. That's going to be -10. Figure out the rest. How do I do this? You know how I asked you guys to finish the back of this for homework? How many of you did that? So you're taking time away from your review. That's okay by me. What am I gonna get? How am I gonna get this? 7+6. Okay? And then -2 + 8, and so on. So you're gonna fill that in. You're not gonna do it right now. We did not use this notation. We didn't use this notation. We used this notation. Same thing. But if that notation messes you up, because it does me a little bit, just because I'm not used to looking at it, if we had learned it that way, it would be fine, but We didn't. Remember this? So remember, I am figuring out we're at B-dubs, how much was my meal plus my dessert? So here's B-dubs, here's my meal and my dessert. So I did 5 times 12. And to that I added 3 times 6. The only time we use this method is if my two matrices are being multiplied together. You guys seem to think that you should use it every single time you see two matrices next to each other. What's happening with these? They're being subtracted. What's happening with these? They're being added. We do subtraction, we do adding. Only when we see them like this do we multiply. On our final, it will be in this notation. This notation will be. Okay? So remember, it's row times column. Row times column. And we wrote our work over here for this one. And then we wrote our work down here for when we did this row times this column. And our work over here for this row times that column. Okay? I'd like you to find that answer. When you add this together, when you multiply this and then add this together, it goes in this first space. Because it's the first column times the first row. So that's where this space is, in the first column and in the first row. Okay? And then we would do the first row, second column. What would be this times this. So over here we have 5 times 10 plus 3 times 4. Okay? Questions on that? Scientific notation, where's my decimal go? Somebody describe to me where my decimal goes on scientific notation. Between the 2 and the 7. Between the first number and the second number. Between the first number and the second number, always. Doesn't matter how many numbers are there, it's always between that first and second. So, 2.7 times 10 always goes there. And then how many times did I move? 6. My decimal starts here because if I'm thinking money, that's a lot of money. Love to have $2,700,000 in my pocket. How about you? Right? So you're going to move that over. 1, 2, 3, 4, 5, 6. Don't worry about the commas. Worry about where your decimal is. Okay? Why is it positive? Which numbers are going to be positive, big or little? Goodness gracious, do you guys need to get up and do jumping jacks or something? Elena's the only one awake. Nice job, Elena. Big, right? You'd like to have this would be a positive thing in your bank account, right? Would you like to have this much money in your bank account? Is that even a penny? No. Not even a penny. So I don't want this much money in my bank account, so this is a negative thing in my life. Right? Where's my decimal going to go here? Between the 3 and the 5. How many times did I have to go to get there? 1, 2, 3, 4. Times 10 to the negative 1. So that's how I remember it. I don't want that much money in my bank account. That's a negative experience for me. So little numbers are negative. Big numbers are positive. Okay? How did we do these? Just right on our calculator. We entered this number, we divided it by this number right on our calculator. Do you remember how you entered that in the calculator? Remember what button we used? It is a times 10 button on some calculators. But what's it on most calculators? E or EE button. So we entered the 8 and then the EE button that to work. That does the times 10, right? And then enter my 5. Divided by 4 EE 3. Okay? Thanks. Questions on that? Okay, we're going to come back and do more. No. I'd like you to take 5 minutes to work on that. Get some answers. We'll go over answers, and then we have another activity with the stations. Okay? If you are done with this, and you want to check your answers, my sheets up here, you can check them while I get the station stuff out. We'll stop recording for a minute. So here's the answers for these 3. Check your answers. Make sure they're right. If you didn't get the right answer, ask me a question. This answer should have been 78, 62, 42, and 34. .7 times 10 to the 6, 3.57 times 10 to the 4. This we did on our calculator. If you got 200, change it to scientific notation. 2.0 times 10 to the 2. This, you may have 6.4 times 10 to the negative 9, depending on your calculator, or you may have 6.0 times 10 to the negative 9. Either of those is acceptable. If you had 64 times 10 to the negative 10, 64 times 10 to the negative 10 doesn't work because this isn't in scientific notation. You have to move that decimal one more place over, and that's where the 10 to the negative 9 comes from. Okay? This is not scientific notation. Looks like it, but it's not fully. Questions on any of those? Nope.